Khanyisani Falaki from Abbott's College, and I'll be taking you through a few tips that you can use to master your paper 2 and get as many marks as you can. This is a paper that most people don't like, but it's actually my favorite. All you need to know is which topics to focus on to get most of those marks. And those topics are going to be statistics. I'm going to look at statistics. I'm going to look at some analytical geometry and some trigonometry. Now, if you look at trigonometry, it's worth 50 marks of the entire exam. So that's a chunk of the marks. The fantastic thing is that most of the trigonometry is grade 10 and 11 trigonometry. So it's mostly things that you already know. Statistics is 20 marks. That's an easy 20 marks to get. Mean, median, mode. It's all formulas, calculator work, and things that you can easily get. And then there's your analytical geometry, which you should already be comfortable with because we all love our squares and our triangles and our rectangles. You just need to make it more formal, which is okay. So the first part, statistics. Most of the stats is just calculator work. If you know how to work with your calculator, it's going to be so easy. It will make everything seem like God-given. It's literally handed over to you, so get those marks. When you interpret standard deviation and variance, you don't need to worry about knowing the normal distribution table. That's fine. It's not examinable. You just need to know how to calculate the standard deviation using your calculator and how to use that to then comment on certain things. Okay, you will be tested on your box and whisker, the 5-number summary, and then analytical geometry. You need to know the properties of your polygons, your square, your triangle, your rectangle. You must be able to know these properties and how to prove them using analytical geometry. So it's very important to be familiar with the exam guidelines because they tell you what is needed, what you need to focus on, and how exactly you can write out your answers. In the trig section, which is a very huge section, even though we know that there are reciprocal ratios, cosec, sec, and cot, they will not be explicitly tested, but if you're comfortable with them, go ahead and use them. The focus will be on trig graphs, so you should know the general shape of your trig graph. You need to know the basics. If you know your basic graphs, then it's easy to then look at the relationships and the transformations and be able to translate what has been given to you. It's easy to see the shifts and the reflections. So know your basics so that you can do all the other things which might need an extra bit of work here and there. Then there's Euclidean geometry. There's no running away from Euclidean geometry. You need to know your proofs. And these are the proofs that will be tested. Line drawn from the center of a circle perpendicular to a chord, line drawn from center bisecting a chord, angle subtended by an arc at the center of a circle, opposite angles of cyclic quadrilaterals, angles between the tangent and a circle, line drawn parallel to one side of a triangle divides the other two sides proportionally. So all of these theorems will be tested. These are easy marks. If you're asked to provide a proof, do it. These are easy marks that you can collect. And of course, your information sheet. The second half of the formula sheet that you'll be given deals with paper 2. So as soon as you get your exam paper, get that formula sheet on that side and deal with it from the first question to the last question because these are actually arranged in such a manner that it guides you. Once you get to the first question, analytical geometry, these are all your analytical geometry formulas, your distance formula, your midpoint formula, and your straight line equations. Know what each formula is used for. Be careful, know the definitions so that when you look at your formula sheet, you don't get confused and spend too much time wondering what equation to use where. Then we have our sine and our area rules. If you look at this arrow, it's upside down with paper 2. Be comfortable. Take your paper, flip it upside down, flip your head upside down if you have to, because you need to be able to see things. You need to be able to visualize things. So do that. Be comfortable rotating things, taking your rulers, changing things around, whatever you need to do in order to be able to see what is in front of you. The second part is compound angles. If you see a compound angle, go straight to the formula sheet. If you see a double angle, straight to the formula sheet. You get a mark for changing a double angle and simplifying it by applying one of these formulas. So as soon as you see a double angle, that's a cos 2x, cos 2 theta, sine 2y, go to your formula sheet immediately, use your double angles. It's literally a memo in your hands. Use it. The last part here is statistics. Then we have probability, and then we have regression right at the bottom. These are all the definitions that you need to know for statistics. These are helpful because if you have a paragraph in front of you, you can actually work out in your head 90% of what you need to do just by reading the paragraph. So when we talk about correlation coefficient, we're talking about R. This is the relationship between two variables. You need to comment on the relationship. Cumulative frequency. When you see the word cumulative frequency, you're most likely going to have to draw an ogive. Cumulative frequency, you have to deal with intervals. Those intervals are called classes. And frequency tables, interquartile range, lower quartiles, maximum. Be familiar with the definitions because when you have that paragraph in front of you and you have to then decipher what the English wants from you and change that into a mathematical statement, these definitions will help you understand what is needed of you. If you see the word mode, modal class, this is the exact same thing. The highest frequency, the number that appears the most. A median, number in the middle. It's statistic. It's the easiest section you can have. Remember, always order your data from the lowest number to your biggest number. And then, of course, useful tools. Remember, for regression, we have the regression formula, a plus bx. When you see the word least squares regression equation, we're looking for this formula, a plus bx. All of that calculator work. You don't have to do much. Take your values, put them in your calculator, and then just be able to comment on what you see. When we talk about the correlation coefficient, R, we want to analyze the relationship between two variables. This table here tells you how to interpret R. If R is equal to 0, and again, you get the value of R, the correlation coefficient, from your calculator. All of this is calculator work. 20 marks in the bag just by using a calculator. If R is 0, there's no correlation between the two values. If R is between 0 and 0.5, you can say there's a weak correlation. Or if R is between 0.5 and 0.8, it's moderate. If R is between 0.8 and 1, you have a strong correlation. And the same works for your negative numbers. We use the same measuring. If it's between 0 and negative 0.5, weak. And the strongest correlation, but it would be negative, of course, would be a strong perfect, which is negative 1. So in this case, if you have a negative correlation coefficient, it means that your regression line has a negative gradient. If you have a positive correlation coefficient, your regression line has a positive gradient. Again, calculator work. These are easy marks. And then we have at the bottom here, know what your box and whisker consists of. Okay, it's the 5-number summary. Easy to get that from the data that you'll be given. It is the minimum. That's the first value. Your last value is your maximum, which represents the upper quartile of your data set. You have Q2, which is your median, and Q1 and Q3. Remember, the interquartile range will be Q3 minus Q1, whereas the range, which is what we're used to, is the maximum number subtract the smallest number. And then once you have your box and whisker, it's very easy to comment on it. That's always going to be a question. Comment on the skewness of your data. Very easy. Just remember this. Once you have your box and whisker, the side of the box that has the biggest area. So if you look at this box, most of my area is on the left-hand side. So it's skewed to the left. If you look at this box right here at the bottom, most of the area is on the right-hand side of this rectangle. So this means that my data is skewed to the right. And if you look at this top example, my box is equally distributed. So that means that your data is symmetrical. Those are useful tools that you can use as soon as you see the keywords, correlation coefficient, know how to use it, box and whisker, know what the 5-number summary is and how to get it from your data. If you look at this over here, there was a similar question in some of the past exams. This is what you're most likely going to get in your exam. This is a very common question. You're given 2 sets of data. You have the height and the length that a few athletes were able to jump. So these are 2 variables, okay? And that's when we use regression and scatter plots. First thing that you do, take this data set that you're given and then substitute it, and then take those values and then punch them into your calculator, because this whole section is calculator work. The important part is to figure out what would be your X, what would be the Y. In most cases, I say, think about influencers. What is the influencer, or who's the influencer, and what is being influenced? And in this case, it is correct to assume that if you have height, it may influence the length that someone is able to jump. So that means our height is our independent variable and our length is our dependent variable. So height would be X and length would be Y. You then enter those into your calculator and you use that to get your R, your regression coefficient. You use that to get your least squares regression line equation by using, if you have your scientific calculator, I've just put it up here. You literally have to press mode once you have your calculator in front of you and practice doing this. Calculator work is very important. And if you're overwhelmed and you're nervous, you might make a few calculator mistakes. So practice doing these steps. On your Casio calculator, press mode, then you press stats, var. You'll see the 1 var option. Enter your X values, press AC, shift and 1. So follow these steps to enter your values. Once you've entered those values and you enter them exactly as it is here, following those steps, you'll easily get your answer for A. So you'll get an option that says A on your calculator. Once you want to get your A, these are the steps that you follow. So once you've entered your values and you now want to get them back, okay, you just press mode after entering your data. You press stats. You choose this, A plus BX, because we're dealing with regression. Once you've entered your X and Y values, you press AC, shift, and then 1. Once you press 1, it means you're able to get those values. What type of values are you looking for? You're looking for the regression value. So on your calculator, you'll see the word REG. That's what you're going to use. And once you press regression, you then have an option. You can press A, it will give you the value for A, which is that value over there. It's part of the equation. Once you then press B, it will give you the value for B. And all you need to do is take those values that you get from your calculator, substitute them back into your equation, and you have your marks. Once you have that, everything else just becomes a comment on the substitution, on what the calculator has already done for you. So I'll go back to that. Once you have your calculator, mode, stats, 1 var if you're looking for values that have to do with the average, the mean, or the standard deviation. Those are the steps that you follow. If you're looking for values that have to do with the regression coefficient, A or B, these are the steps that you follow. And that's how you get your values for the equation. If you look at these questions here, once you have your equations, you then asked to comment on what you notice, or to use what you have, use the mathematical model that you've created to make predictions. So if you look at this third question, estimate the height of a long jump athlete who jumps 7.7 meters. So take what you have, what you're given is 7.7 meters. Okay, what you're looking for is the height. So substitute that. You know that your height is your X, your Y is the length. So at number 3, substitute your 7.7 for length and then use that to solve for X, which is your height. If you look at this question, determine the correlation coefficient. You don't have to do any fancy calculation. Once you've entered your data into your calculator, using this, pressing mode and stats. You then press regression. Once you've entered your data, shift 1, go to regression and choose the option that says R. It will give you a value for R. And in this case, you can see that R is 0.8. And if you go back to the previous slide, you can then use this table over here to determine what that R means. If R is 0.8, you comment on it. This is always the structure of the questions. The correlation is strong because we have 0.8, and it's positive because that number is positive. Remember, R will always be between -1 and +1. If you get a number that's outside of that range, you've done something wrong. And again, if you have a sharp calculator, you may have some problems with this section. So try and arrange or get a Casio scientific calculator for your exam. It will make your life easier because most of this work is calculator work. And then the easy stuff, the grade 8 stuff, the grade 9 stuff, mean, median, and standard deviation. Again, calculator work. As soon as you asked about the mean or standard deviation, you use this first row of instructions. These are the same instructions from the previous slide. I just have them here. Same thing, same type of entering onto your calculator. So here you're looking for the mean or standard deviation, which means you're going to follow these instructions. Mode, stats, 1 var, enter your data values, press AC, then shift, then you press 1 to be able to get those values back. And because you're working with the variation in your data, we're looking at mean or standard deviation. You're going to choose the VAR option, which stands for variation. And if you ask to find the mean, you're going to use the X bar symbol, press the X bar symbol. Or if you ask for standard deviation, it's that sigma symbol. All of this calculator work. Tap that into your calculator, enter your data, and you literally have the answers in the palm of your hands. If you're comfortable with the calculator work, you can get all the 20 marks from this section. So the first one says, determine the mean. All you need to do is enter these X values into your calculator following these steps, and then you'd get 28.5 as your mean. Find your standard deviation. All of that is calculator work. All you need to do is make sure that you enter the values correctly, calm down, make sure you don't make any mistakes, and then be able to trust the values that you have in your calculator, because if you're in a rush, you might make a mistake and you might end up getting the incorrect values. And then here, the box and whisker, it's a 5-number summary. This is the easiest section in math. All you need is to look at your data, arrange it in ascending order from the smallest number to the biggest number. So the 5-number summary consists of your minimum, the smallest value in your data set, the Q1, which represents the first quarter of your data set, Q2, which is the median, the number in the middle of your data set, Q3, the third quarter of your data set, or your 75th percentile, and lastly, the maximum. Those are the 5 numbers that you use to draw your 5 or your box and whisker diagram. And once you have your box and whisker, you're always going to be asked to comment on the skewness of your data. And as we looked at this diagram before, if most of your area is on the right-hand side, then your data is skewed to the right or skewed to the left if most of the area is on the right. If most of the area is on the left-hand side, then your data is skewed to the left. Now, here is a common question that you're most likely going to find in an exam. You're given the box and whisker. You're not given any values that you have to sort or arrange. The box and whisker is already drawn for you. All you need to do is translate the information, analyze the information, and comment on it. So here, what is the highest number? What is the maximum temperature? If you know what the 5-number summary is, you'll know that the maximum is 36 because that's a maximum number. What is the minimum? It's 20. What is the number in the middle? 28. And then they ask for the interquartile range at D. The interquartile range is looking at the 75th percentile, which is Q3, and your 25th percentile, which is Q1. So it would be Q3 minus Q1. And then once you are familiar with those concepts, everything else becomes very easy. How many days had a maximum temperature that was lower than 28 degrees? So 28 is in the middle, which means 50% of our days had a percentage or a temperature that was lower than 28. Once you know the basics, it's easy to then be able to deal with what's in front of you. And again, I'm bringing this up because if you understand how to translate or what you have in front of you, it's easy to answer the questions. And then lastly, frequency tables. When you see a frequency tables, think ogive, accumulated, accumulation. So in order to draw your ogive, in order to deal with frequencies, you need to understand how we get these values. It's accumulated. So A in this case would be 34. You haven't accumulated anything, you just have 34 over there. Know what everything is on this table. This first part, those are your intervals, your class intervals. And if you're asked to draw your ogive, remember, always use the upper class or the upper bound of these intervals. And you draw your ogive using your cumulative frequency and your upper bound of your classes. The ogive looks like this. Remember, this shape is very important. It's a curved shape. If you have something that looks like a straight line or something that looks like a box, it's wrong. This is the S shape that you should always have for your ogive. Ogives will always be grounded on the x-axis. They shouldn't be flying up there. And look at this and that. That S value is very important. And using your ogive, again, 5-number summary, you should be able to plot your box and whisker from it. And if you understand what the box and whisker with the 5-number summary is about, it should be able to then be able to interpret what the ogive represents. Again, remember, you use the upper bound of each class interval to plot your ogive, and your cumulative frequency will be on the x-axis, and then your upper bound will be on the x-axis, and your cumulative frequency will be on the y-axis. And then lastly, analytical geometry. Again, as with the previous section, it's important to know the definitions because they will help you understand what is wanted from you. If you see the word bisect, it means cut in half. So you're probably going to have to use the midpoint formula. This is an awesome and easy section because it's handed to you. It's on the formula sheet. Everything you need for this section is on the formula sheet. So familiarize with the formula sheet. Use these definitions with your formula sheet to kind of figure out what you need to do for a specific question. And as I said, your formula sheet is structured such that the first question in paper 1, those formulas are going to be in the first section of your formula sheet, or the first half of your formula sheet. And know when to use each formula. Look for the keywords so that you know when to use them. And then most importantly, the angle of inclination. Most people struggle with this section and it's really not that difficult. It's very easy. Just remember, the angle of inclination is the gradient. If you can find the gradient, which you can because you've been doing this since grade 9, then you know how to use the angle of inclination because the angle of inclination M is equal to tan theta, is equal to gradient. Angle of inclination equals to the gradient. So in this case, we have examples where you are given the angle of inclination and they're asking you to find the gradient. Remember, the angle of inclination is equal to the gradient. If you have a gradient, you have the angle of inclination. And then the midpoint formula, very easy. Familiarize yourself with the formula sheet. If you see midpoint, if you see bisect, go straight to the midpoint formula. Look at the 2 points that you're given, or the 2 coordinates that you're given. Substitute that into your midpoint formula. It's the one with the M for midpoint. So substitute your X and Y coordinates into the formula and you easily get your coordinates. This is an awesome section because everything is on the formula sheet. And then we have our trigonometry. This is a very heavy section in paper 2. But it's also very easy. If you stick to the basics, don't worry about all the complicated things. Familiarize yourself with the basics. Sine, cos, and tan. Those are your trig ratios. When you have a 90-degree triangle, understand what it means, how to use them, how to find sides using your trig ratios. What do you want? What do you have? and then use that to find your answers. Remember your special angles. If you see 30, 60, 45, those are special angles. You don't have to study the special angle table, but be able to recognize special angles because you can literally just use your calculator for that. Use what you have to get what you want. Then there are our reciprocal ratios. You're not going to be tested on cosec, sec, and cot, but if you're comfortable with them, that is great. And then know, how do you enter them into your calculator? It's 1 over sine theta. You enter it exactly as you see it. And then your trig ratios. Isolate the ratios. You treat it exactly as you would treat an equation. Isolate your ratios. Use shift on your calculator if you're solving for a specific value of theta. And these are the examples that you can go through, which go through different types of equations. Isolate your trig ratio and then use your calculator to solve the angle. And then the other part of trig, Cartesian plane, be comfortable with this drawing. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Remember, we look at the quadrants in an anti-clockwise direction. Okay? Understand when to use the quadrants. If the question is asking for a sketch, we want a quadrant diagram. Look at what you have and use that to get what you want. Okay, and then using the quadrant diagram, we then go to reduction ratios. The reduction ratios are very important. If you don't understand how we get to these ratios, cram them. Just know them. Know that in quadrant 1, we have theta. That's where all the ratios are positive. In quadrant 2, when you have 180 minus x, that's where sine is positive and only sine is positive. In quadrant 3, 180 plus x, that's where tan is positive. Again, look at the name, reduction. So we use reduction ratios to simplify, to reduce trig expressions. So if you have an expression like this example where it's cos of 180 plus x, you don't want that 180 plus x, you want to reduce it. So then you look at your quadrants over there. 180 plus x is in quadrant 3. Only tan is positive in quadrant 3. That means that this cos would then be negative. Sine of 90 plus x, and then that's something else. We use co-ratios for that. And because 90 plus x is in the second quadrant, sine is positive in the second quadrant, it means that your answer is going to be positive. And even though using co-ratios and sine changes to cos, whenever you see a 90 or a 270, it will still be a positive cos. And then your general solution, remember, with sine and cos, with general solution, you must add at the end of your calculation plus 360n. With tan, all you need to do is add plus 180n. And the reason for this is because the period of your cos and your sine graph are 360 degrees, and the period of your tan graph is 180 degrees. So remember, use your quadrant diagram. For cos and sine, it's plus 360. For tan, it is just 180 degrees. And then there are different types of equations that you must be familiar with. So for this one, you have co-functions. So whenever you see a 90 or 270, use co-functions. Here you have cos and cos. Choose one of those sides. You have cos on the left, cos on the right. Choose one of those sides, and one of those angles will be your reference angle. Okay? If you master the basics, the difficult things will be easy. Sometimes you have to use your identities. Remember your trig identities. And whenever you see cos, change it immediately to sine. Whenever you see tan, change it immediately to sine over cos x. If you see something squared, use the Pythagorean identity. Sine squared plus cos squared is 1. These identities are always going to be tested, right? So remember, whenever you see tan, change it to sine over cos. If you see something squared, it's most likely this identity, and these are the other forms of that identity. So if you have an equation that has squares or looks a bit complicated, go to your identities. And remember, in grade 12, we introduced a couple of new identities, your compound angles and your double angles. And when you have to use identities, it's very important. Remember, only work with one side of your equation. If the question says prove, only work with one side of the equation. And again, go back, use your identities. Tan will always be sine over cos. Sine squared plus cos squared will always be equal to 1. And then as soon as you see your triangle, look at the bottom part of your formula sheet. That's the sine, the cos, and the area rule. When do you use sine? When you have two angles and two sides involved. When do you use cos? When you have two sides and an included angle. When do you use the area rule? When the question asks you for area and you have two sides and an included angle. Remember, this can be used for any triangle. It does not have to be a 90-degree triangle. And then lastly, your compound angle. This is very simple. If you see something strange, if you see something that does not look familiar to you, you don't see your usual special angles, your 30, your 45, your 60, then you probably have to use compound angle identities or double angle identities. So try and manipulate what you have some way so that you can make it a sum of two things or a product of two things, such that you can use your compound angles or your double angle identities. Thank you.
Which is a village outside of Polokwane, and I was raised by my grandmother. A lot of creatives I know come from rural areas. I always make sure that I mention where I'm from. Like Gcagamaja, like it's quite an important thing for me, because for a kid who grew up the same way I grew up, I didn't have role models who came from where I was from at the time. But I think it's quite important to see someone in the creative space as a photographer saying I'm from this place, and you see them doing all this great stuff. For artists and for especially people in the creative spaces, I think it's quite important for us to always mention where we're from in order to inspire other kids who grew up the same way we grew up. I think with me continuing to shoot the spaces that I've been familiar with, especially shooting Kokasi in the township and shooting in town, it's taught me the importance of representation, especially as a black person. Because I feel like for a very long time, our stories were not heard strong enough, or they were not heard enough. There's something affirming about your story being told honestly. There's also something really affirming about seeing someone who looks like you on a different level that you didn't think that you can get to.